Hello everyone. In this video, we are going to look in detail about one of the major OOPS concepts, inheritance. In Java, the presence of inheritance is everywhere. In my opinion, it is almost impossible to write a Java application code without using inheritance. You might already have a brief intro to inheritance in Java from OOPS overview episode. If you look back at the tutorial series, almost in every episode we had references to inheritance. In fact, we had detailed code example explanation with inheritance for abstract classes and interfaces. So, assuming you are already aware a little bit on inheritance, we'll go in depth about the concept now. Inheritance is the mechanism in Java where class is allowed to inherit all the features of another class. The features involve fields or variables and methods. This occurs with parent-child relationship. That is, when the child class acquires all the properties and behavior of a parent class. In Java, inheritance is achieved by using extends keyword. Example: inheritance provides means to create new classes based on existing ones, thus allowing us to reuse the code and add a new code on top of the existing code. Why do we need inheritance? Java applications might contain hundreds or thousands of classes. There may be other programmers working on the same application. It is inevitable at some point there will be a piece of code that will be used by multiple programmers on multiple different features or functionalities. If we have duplicate code on every such case, it will be extremely difficult to maintain the application. To avoid duplicate code and induce reusability, we need inheritance. Reusability is one of the most important feature and use of inheritance. The code written in parent class or the superclass is common to all the child or subclasses that extends it. The child classes can directly use the code available in parent class that has visibility. Apart from reusability, method overriding is achievable only through inheritance. The method overriding or runtime polymorphism helps in having generic code based on the parent class. It provides multiple implementations of the same method which can be used to enhance or improve functionality. Finally, inheritance supports abstraction by which only the necessary features are shown. There are a couple of important terminologies in inheritance that you must be aware of. Superclass, also called as parent class or base class. This is base class whose features are inherited by other classes. Subclass, also called as child class or derived class or extended class. The class that inherits the other class is known as subclass. The subclasses can have its own fields and methods in addition to the superclass. Easier relation. In OOPS, the concept of easier relation is based on class inheritance or interface implementation. Easier way of saying this thing is a type of that thing. In object orientation terms, we can say like the following: car is a vehicle means car extends vehicle. Ferrari is a car, that is Ferrari extends car. Other examples would be orange is a fruit, surgeon is a doctor, etc. In different terminologies, we can put like these: vehicle is the superclass of car, car is the subclass of vehicle, car is the superclass of Ferrari, Ferrari is the subclass of car. Ferrari inherits both vehicle and car. Ferrari is derived from car. Ferrari is a subtype of both vehicle and car, etc. Types of inheritance. There are different types of inheritance in Java: single level, multi level, hierarchical, hybrid, and multiple. Classes support only four types of inheritance except for multiple inheritance. Only interfaces support multiple inheritance. Single level. In this type, the subclass inherits the feature of one superclass, a simple parent child relation. Multi level. This is a grandparent type. A derived class will inherit a base class, where the derived class will act as a base class for other derived classes. Here, child class extends parent class and grandchild class extends child class. Hierarchical. One parent class inherited by multiple child classes. Here, One parent class is extended by multiple child classes, child 1, child 2, child 3, etc. Hybrid. From the name itself, it is a mixture of already defined inheritance types. It can be combinations of hierarchical, multi-level, and single-level inheritance classes. Multiple. Java does not support multiple inheritance of classes. Only interfaces support multiple inheritance. One child interface has multiple parent interfaces. Advantages of inheritance. Reusability. The subclasses can reuse superclass fields and methods, eliminate code duplication, and allows code reusability. Maintainability. Inheritance promotes abstraction and encapsulation, making the code easier to maintain and extend. Runtime polymorphism. Runtime polymorphism or method overriding provides multiple implementation of the same method which can be used to enhance or improve existing functionality. Disadvantages of inheritance. Complexity. When we start using hierarchical and hybrid inheritance, the level of code complexity increases and it becomes harder to understand. In general, inheritance can make the code more complex and harder to understand. Tight coupling. Superclasses and subclasses form tight coupling. This makes it difficult to make changes to the superclass without affecting the subclass. In any application, too much of tight coupling will result in poor quality and high maintenance cost. Let's look at some examples to understand in detail. First, let's look at single level inheritance. Created a base class called SampleParent. Couple of constructors on SampleParent class to illustrate how the super keyword works. The default constructor will be called whenever an object is created with a new keyword. The parameterized constructor for showing call from the child class. One public method and one protected method. While the public method can be accessed from anywhere, the protected method can be accessed only from the classes that extends sample parent class. Then child class for the sample parent extends it. Here we have a default constructor sample child. The first line in the constructor is the super keyword with a string argument. This indicates call to the parent or superclass parameterized constructor. The call to the superclass constructor must be the first line in the constructor body. It is the rule. When we try to move, you will see error like this. This call to super cannot be present anywhere else. The super keyword can be present only in the constructor body and it should be the first line. If you don't specify super keyword in the child class, Java will automatically call parent class default nor constructor if available. Hence, super keyword is not mandatory. We have a method to call the parent class protected method as well. To demonstrate the working, created class demo single inheritance. Inside the main method, first creating an object for sample parent class. As we create this object with the new keyword, the default noarg constructor will be automatically invoked. Then object for sample child class. Here the new keyword will first call the default constructor of this child class. The keyword calling the parameterized constructor of parent is the next, and finally the print statement. Let's keep breakpoints to see the exact execution flow. You can see how the execution shifts from child class to the parent class. In case if you don't have this super statement here, then the parent class default constructor will be called by default. The execution flow goes like this. After this, we have calls to other methods on parent and child classes. The final part of the code in the main method to if control statement is just to explain about instance of. We will look at control statements in detail on later episodes. For now, simply understand that if verifies whether the condition within is true. If true, the block of code will execute, otherwise it won't. The first if condition checks if the sample child and the sample parent objects are equal. This statement will be false. Though sample child class inherits sample parent class, the objects created for them are not equal. You might need a deeper understanding of equals and how it compares, which will be explained on later episodes. The second if statement checks if the child class object is an instance of sample parent class object. Here, this will be true. The easy relation between parent and child class enables to check instance. Whenever you want to compare whether an object of one class is an instance of another class, we will use syntax like this. The instance of keyword is important, and while coding complex application that uses existing libraries, often it will be used. Let's execute and verify the output. Everything is printed as expected. The other part, implied supercall from child to parent class, can result in compilation error. Take this class, sample parent test. For example, we have only one constructor that is parameterized with a string argument. As you are aware, Java will not create a default no argument constructor because there exists already a constructor. The class sample child test extends parent class and has parameterized constructor as well. The problem here, the first line on the child class is implied supercall. But as the parent class does not have no argument default constructor, this results in compilation error. Moving on to multi-level inheritance, which is grandchild relationship. Here is a class sample grandchild that extends sample child class. This is multi-level inheritance as sample child class extends sample parent class. Demonstrate the execution have class demo multi-level inheritance. In the main method, simply created object for sample grandchild class and have method calls. Here, what will happen? Since no default constructor is specified for sample grandchild, Java will automatically create one. But automatic default constructor will have the super call as the first statement, which will execute parent class default constructor. Hence, the sample child default constructor will be called. On sample child default constructor, we have explicitly specified super keyword called parameterized constructor of sample parent class. Hence, that will be the first to execute. Let's keep breakpoint and see how the execution flow goes. From grandchild class to child class and to parent class constructor. Let's verify the output. For another types of inheritance hierarchical, created another class sample child2, which also extends sample parent class. This is siblings structure, that is, one class is inherited by more than one child classes. The sample parent class is inherited by both sample child and sample child2. And sample child2 have overridden print method of sample parent class. This is runtime polymorphism or method overriding. So when we create an object of sample child2 class and call print method on runtime, Java will call child classes print method. Let's keep breakpoints, execute and verify the outputs. As you can see, the execution flow goes here. All the statements are printed as expected. Finally, multiple inheritance. We had already seen a little about this on interfaces episode. So, we'll not go in detail. Strongly remember, Java classes does not support multiple inheritance. Only interfaces support this type of inheritance. We have interfaces SampleA and SampleB. Each have an abstract method. Then interface SampleC, which extends both SampleA and SampleB interfaces. Since sample C is also an interface, we cannot provide the implementation of abstract methods. But if class implements sample C, it must have method implementation for all methods in sample A, B, and C interfaces. Now we have class sample multiple inheritance. Any of the methods in the interfaces is not defined on this class, then we will get an error. So you can see, not defining any one of the method on interfaces, we get error. To demonstrate execution that created demo multiple inheritance class inside the main method, created object for sample multiple inheritance class and calls to each of the interface methods. Let's execute and verify the output. Everything is printed as expected. Haven't shown an example for hybrid inheritance as it will be simply a combination of different types. I prefer to avoid hybrid inheritance as it makes the code complex. Unless it is absolutely necessary, recommend try to avoiding hybrid inheritance in Java project. Let's recap with a quick 2-minute summary. In Java, the presence of inheritance is everywhere. Inheritance is a mechanism in Java where class is allowed to inherit all the features of another class, occurs with parent-child relationship. That is, when the child class acquires all the properties and behavior of a parent class. In Java, inheritance is achieved by using extends keyword, need for inheritance. To avoid duplicate code and induce reusability, we need inheritance. Reusability is one of the most important features and use of inheritance. The child classes can directly use the code available in the parent class that has visibility. Method overriding is achievable through inheritance. It provides multiple implementations of the same method which can be used to enhance or improve existing functionality. Inheritance supports abstraction. Superclass, also called as parent class or base class. Subclass, also called as child class or derived class or extended class. The concept of easier relation is based on class inheritance or interface implementation. Easier is a way of saying this thing is a type of that thing. Something like car is a vehicle. Types of inheritance: single level, multi level, hierarchical, hybrid, and multiple. Classes support only 4 types of inheritance except for multiple inheritance. Single level. The subclass inherits the future of one superclass. Multi-level. This is grandparent type. Derived class will inherit a base class where the derived class will act as a base class for other derived classes. Hierarchical. One parent class inherited by multiple child classes. Hybrid. It can be combination of hierarchical, multi-level and single-level inheritance. Multiple. Java classes does not support multiple inheritance. Only interfaces support multiple inheritance. One child and multiple parents. Advantages of inheritance: reusability, maintainability, and runtime polymorphism. Disadvantages of inheritance: complexity occurs mostly when we start using hierarchical and hybrid inheritance. Parent child relation leads to tight coupling. After every topic, there will be a set of questions with multiple choice options which you can use to self check your skill on that topic. These are derived by me for that topic. You can find the answer in the video description. In case you got it wrong, no problem. Explore and identify what you missed. This exercise will help you learning the programming language efficiently. First question. Second question. Third question. Fourth question. Fifth question. Arrived by creating classes with parent-child is a relation and objects for different types of inheritance as shown in the examples. It would be impossible to find a Java-related application without inheritance in it. In every Java project, at some point of time, you would require to reuse common code for some reason. Among the different types of inheritance, single level inheritance is the most used. Like everywhere, the efficiency of inheritance depends on its design and how it is implemented. I have used inheritance almost in every application that I have coded, mostly with a single level, sometimes hierarchical and multi level. I try to avoid hybrid inheritance. Also, I restrain myself from creating many inheritance classes. Too much of anything is bad, and I strongly recommend to use inheritance efficiently. Make sure you are clear and confident on using inheritance efficiently. Thank you.